So yesterday I was in this slide, right? Okay. So I was teaching about the traditional method as well as the that simulation method. So as I told you, traditional method is nothing but okay, it will follow this step-by-step process. So first design, I told you after product design engineer. Okay, once he decides, okay, this is the better design, then he will give the sketch prototype for the design team. Okay, the design team will convert the sketch prototype into the 3D modeling by using the CAD software. Then it will go for physical prototype. Okay, this is with respect to the traditional method. Before, I think around 30 to 30 years back, okay, they were going directly to physical prototype because they were not using the simulations, okay, to solve the problems. So only after the after the 3D drawings, okay, immediately, okay, uh, they were fabricating the parts, okay, or components. So they were going for physical prototype, then they were testing, okay. If something error comes into picture, so immediately the product design engineer, okay, he was redesign. He was again he has taken the design and he has modified the design. Okay, see if be careful in testing if it is got the error. Okay, if it fails, example, for the particular boundary conditions for the particular load. Okay, if the material fails, again that design, okay, that design will go for remodeling. Okay, I'm telling you, this is with respect to the traditional method. It is before 30 years back. Okay, so they were going for redesign. After redesigning again, okay, they're fabricating the specimen. That is, they were doing the prototype. Again, they were doing the testings. Okay, if the results are okay, okay, if the results are good, that the material can withstand the load or the material can withstand the boundary conditions. Okay, then only, okay, they were going to build the original prototype or original specimen or original prototype. So this was the old passion, I think 30 years back. But right now, okay, almost from last 15 years, okay, 15 years, this simulation has been occurred from 2002, I think. ANSYS Workbench as well as ANSYS Workbench was exist in India around in 2002 or 2003. Okay, so this simulation exists, I think between I think 15 to 18 years back. Okay, so here in the virtual type, okay, first the same thing is, okay, the designing part is finished by using the design softwares like CATIA, Prio, or SolidWorks. Okay, Prio. They were converting the sketch prototype into the 3D modeling. After that, okay, the simulation exists. Okay, in the virtual type or virtual manufacturing. Simulation is nothing but by using the softwares like ANSYS, Abacus, Nastron, Pattern. Okay, they were using the softwares to solve the problem. Okay, if in that simulation, if the results were negative, or if they tell if the material cannot withstand that much load, okay, or regarding to the boundary conditions, okay, again the means analyst, that is your FEA head, okay, will tell, okay, this design is not good. But again the product design engineer will take the design, again he will try to remodel, okay, the design. And then after remodeling the design, okay, he was sending the new design for the simulation. Okay, if it is okay, then only, if the results are okay, then only it will go for build. So this is with respect to, okay, now all the companies are following the second one. Okay, see, first one, if they follow, okay, see, for fabricating the physical prototype, okay, you want money, you want to invest cost, you want to invest the time. Okay, everything will be wasted. Okay, the money, material, cost, okay, whatever. See, everything will be wasted if they use the simulation softwares. Okay, so there is no investment of cost. Okay, there's no investment of the material, so there's no investment of the manpower. So everything we can save by using simulation. So for that, what they're doing now, okay, they're doing, so they're seeing the actual prototype, okay, in the form of the virtual. Okay, they're manufacturing, sorry, so they're designing, okay, the product, okay, in a software. Okay, they are doing the analysis by using some software, and and they are seeing whether the material can withstand the load or not. I think yesterday I told you about the car, right? When the car is moving around 200 km per hour, so what is the airflow? So you can find in CFD by using the software like CFD, that is computational fluid dynamics. So you can see everything. So where is the stress concentration is more? Okay, when there is hitting the car, so where is the where is the stress concentration is for in the car body, as well as what as well as how the air is flowing. So you can see, you can analyze everything in the software. So there is no need for means conducting practically. Okay, so once the results are okay, okay, with respect to the company rules, then after that only they will go for building the original prototype or original model. So this is what you can see in the second second figure. So this is concept of VM, that's virtual manufacturing. So initially everything. Okay, so initially you can see the all the what you can say, while going to manufacturing. Okay, they'll not go direct to manufacturing after the design part. Okay, they'll use this system. Okay, they'll use the computers to solve the problem, to analyze whether this product design is okay. Okay, whether what these conditions are, these what you can constraints. Okay, if you apply these constraints to the material, whether this material can withstand or not, everything we can analyze in the system. We'll get the information, all the information, okay, through the system. If you want to change the design, or if you want to change the some speed of the spindle, or speed of the, or if you want to analyze, okay, around 300 kilometers per hour, when the car moves around 300 kilometers per hour, so what will happen, how the air is how the air is flowing, whether this stress concentration can change from one point to other point, everything we can analyze in system now. Okay, if you have the laptop, okay, with high configuration, so you can do simulations in the software itself, and you can see the manufacturing of the, or you can see how uh, the product works. Okay, in the form of reality. First, we will see in the systems. We'll analyze. Okay, if you want to change the design, if you want to control the design, everything we can do in systems. Okay, once the higher ups, that is higher management, approves everything, then only the product design engineer will send the product, the what you can say, the 3D model. Okay, 3D actual model. Okay, to convert from the virtual into the reality. Okay, so this is called as concept of VM, virtual manufacturing. First we will see everything in the systems. Okay, in the computers we will solve everything in the computers. Okay, make it in a computer, all the design part, analysis. Okay, whatever it may be, you solve and you analyze in the system. See virtual reality. See virtual reality means seeing the design. Okay, then modeling, running the prototypes. Okay, either it may be CNC machines, either it may be the cars, or any product. Okay, you can see with respect to moving. Okay, moving from one point to other point, you can see everything. You can see the design part, how it looks. Okay, you can show for the customers. Okay, customers can feel, okay, like a real product. Okay, they can see the product, they can analyze how it moves. Okay, what is the capacity of the car, so how the CNC machines are moving. So what is the constraints we can give? What is the maximum spindle speed we can give for for the CNC machine? What is the cutting speed? Okay. So what are the different types of tools we can use in the CNC machine? Everything we can analyze virtually. Okay. That's what virtual reality. Virtual reality means in the working in the virtual environment. Okay. So that if a company satisfies with respect to virtual reality, virtual manufacturing, generally they will send all the informations, okay, to the real manufacturing of the prototype or the product. So you can see in these two figures. First, we will do imagination in these systems. We will try to analyze whether this material can withstand the load, or this material or this design is good, or whether this product can run for 300 kilometers per hour. Okay, what is the stress concentration? So what is the air flow? Okay, whether this air flow will make the car whether the airflow, okay, will vibrate the cars with respect to that much speed. So everything we can analyze initially with the virtual manufacturing. Then if if the conditions are okay, if the results are okay with respect to the design department or product design engineer, then he will send that design to original. Sorry, he will send the design to the manufacturing department. Then only we will tell, okay, go for manufacturing the products. So you can see in the second figure, make it physically. So first we will make in computer, we will see everything, and then we will send the design part for the manufacturing, okay, to complete the process, or to complete the prototype, or to complete the product. Okay, see, once the manufacturing comes into picture, okay, here if you see in the second figure, manufacturing, if you're converting into product, then you want raw materials, then you want manpower, then you want the real CNC machines, okay, then equipments, or technology, okay, and material, okay, everything you required here in the manufacturing department, okay, then whatever you analyze in the virtual manufacturing, okay, you will convert into the real product. So this is what, okay, it is conveying in the industry right now. Okay, if you go for industry, everyone should understand, okay, it is very, very important. Within next 3 months, okay, you'll be going for industry, okay, so you should know all these things, what is virtual manufacturing, okay, what they will do in virtual manufacturing. So these things are very important for you, okay, because uh, I don't know, within 3 months, lot maximum students will go for industry, okay, either they will go for design department, or analysis department, or manufacturing department, okay, they should know what they will do first. So simply they will not, simply once the design is finished by product design engineer, okay, directly it will not come for manufacturing. First they will analyze in the virtual manufacturing, then only if the conditions are, if everything is okay with respect to the product, the analysis is okay, or or the whatever it may be, okay, if you go for automobile industry, the virtual manufacturing, what you can say, it will be different. If you go for aerospace industry, okay, that will be different. So you should know what is virtual manufacturing, what they will do in the virtual manufacturing, okay, they will see everything in the computer, in the system, okay, then if the results are okay, then only they will send all the information for the manufacturing department, okay, to manufacture the products. When it comes to manufacturing, you want to invest money for buying the raw materials, you want to invest money for the for the manpower, okay, you want to invest money for the for the machineries, okay, like CNC machine, or rapid prototyping machine, whatever it may be, okay, you want to invest for the technology, okay, what you are using. So everything you should invest the money in manufacturing department. But if you come for the computers, okay, only the initial investment is, in initial investment you want, that is, if you want to purchase software like SolidWorks, then I Aprio or Pro E, okay, initial investment you should put like 4 to 5 lakhs rupees, okay, for analysis around 30 lakhs rupees, the initial cost will be high. But later on, okay, later on, to do the analysis, okay, it will be easy for you. So initial investment is high, but later on it will be easy for you to see the results, okay, immediately you can see the results. So there is no need for going to manufacture the original product, and you want to see, okay, so this is what, okay, you want to know in the industry. Then if you come for the next slide, so what is VME? What is VM? That's virtual manufacturing. You can see virtual manufacturing is a manufacturing in a computer, I told you. So manufacture, you will do manufacturing in the computer. So whatever you want to assembly, you want to do assembly, you can do assembly of the car, okay, you can do in system, or you can do in computers. Okay, you want to do analysis, that I told you, when the car is moving 200 kilometers per hour, you can do the analysis, and you can find the stresses, you can find the strain, you can everything, okay, whatever you want, okay, you can find the solutions, okay, for the input, whatever you give the input, okay, finally it will give the output. You can do the fatigue analysis, you can do the creep analysis, whatever you want, okay, you can do in virtual manufacturing. So virtual manufacturing is nothing but a manufacturing in a computer. So you will manufacture a product in a computer, not in a not with respect to real manufacturing. Okay, this is a imaginary. This is called as virtual manufacturing. Is called as imaginary. So you will imagine the design. You will convert that imaginary design into the manufacturing in a computer. Then, if the results are okay, then we will send that design to the original manufacturing department to convert from computer manufacturing to real manufacturing. Okay. So next, virtual manufacturing is a manufacturing of imaginary. I told you, right? It's called as imaginary. So virtual manufacturing is a manufacturing of imaginary objects in an imaginary or virtual environment to attain concrete objective. So I told you, right? It is an imaginary. So be careful. This is called as imaginary objects. Objects indicates the products. Okay, this is called as manufacturing of a imaginary products. Okay, in an imaginary or virtual environment. So we'll create a virtual environment and we'll create the products and we will analyze. So what will happen? So we'll create the model, okay, and we'll apply the boundary conditions and we will see. So what is happening? So what is happening in a virtually, not in a real world. Okay, we'll not go for real manufacturing. So we'll model the design, we'll apply the boundary conditions to it, and we will see whether the material can withstand the load or not. That is, it may be static load or it may be the fatigue load, whatever it may be. We'll apply the boundary conditions according to the customer needs, and we will see whether the material can withstand the load or not. So this is called as virtual environment. So we will solve the problem with respect to the virtual environment. If the results are okay, then only we will send all the information to the manufacturing department. So we can see at the end, the third line, an integrated synthetic manufacturing environment exercise to enhance all levels of decision and control. I told you. So here always you will be having control in the computers. You will be having control. So if the design is not good, then immediately you can change the design. Okay. So there's no wastage of the material. So you are designing with some software, right? So you solve. If the design is not good, okay, then go to redesign the model. Again, you redesign the model, do the analysis. Okay, if the results are not good, if the results are telling this design cannot withstand the load, again go for redesigning the model. So here you can waste the time. Okay, here you can waste the time, but there is no necessary wasting the cost, sorry, wasting the raw materials, wasting the manpower. Okay, then wasting the machineries. So anyway, if you go for real manufacturing, okay, you want machineries. Okay, so there is no wastage of machineries. Okay, so this is what is called as virtual manufacturing. Okay, virtual manufacturing is called as imaginary. So we will imagine the design, we will make a design in some softwares, we will analyze and we will test. Okay, if it's okay, then only we will come for the real manufacturing. Okay, I think everyone can see here. So virtual product development in CAE based simulation. So CAE means computer aided engineering. So that is your FEA, that is finite element analysis. Okay, CAE based simulation. You can see there are three figures. One is the input parameter, then CAE process, then response value. So what is the meaning of this? So input parameters is nothing but about your design. So what is the geometry of the product? So what is the material properties? That means whether you are using the aluminum for this product, or you can say the steel, mild steel, or you can go for a polymer composites, or you can go for alloys. So what is the material so that you're using for this product? Okay, so that is what is called as material properties. So you should give the geometry. What is the geometry of the shape? Like if you want to go for the automobile parts, like IC engine. So what is the geometry of that? So what is the material you're using? So what is the material property for that? So this is called as input parameter. So input parameter you should be always you should be careful. If you go for analysis, your answers your FEA. Okay, first is preprocessor. So I'm telling you preprocessor. So preprocessor is nothing but, okay, giving the inputs. Okay, that is your geometry, your the properties. Okay, your material properties, as well as you should define the area, you should define the you should define the what type of elements you are using. Okay, everything will come under the preprocessor. Okay, elements, what type of element, 1D element, 2D element, 3D element. Okay, or 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 you are using the different types of elements. Okay, this is called as input parameter. That is called as speed processor. So next is CAE process. See, after modeling the structure or modeling the if you go for IC engine part, okay, anything, it may be crankshaft, connecting rod, then piston, whatever it may be. Okay, after doing the modeling, then go for simulation, then apply the boundary conditions, okay, according to the customer needs, and find the solution. So that's called simulation. So once you do the simulation, once you solve the problem, so that is solved. Okay, it will come in the answers, it will come solved. So preprocessor, solver, post processor. Okay, see, in solver you should solve the problem. Okay, it will use some equations to solve the problem. Okay, so then it will give solutions. At the end, it will give the solutions. Depending upon that solution, you should say whether this material can stand the load or not, depending upon the stress. okay, stress induced in the material. So whether the material can withstand this much load or not. Okay, according to the results, we should go for that is your third is response values. So this represent whether the product this product can sustain or it can function regarding to the customer needs. So functionality, I told you, functionality is nothing but once you get the results, you should analyze whether whatever the customer is asking, whether this material is withstanding or this material can sustain what they're asking. So that's first functionality. So whatever the customer is asking, the product is giving the same or not. Okay, that's first functionality. So this is response value nothing but depending upon the customer needs, we should analyze whether this material is withstanding or not. If it is not withstanding, then we should change the design. So that is called as response value. You can see here product functionalities. If the product is not function, if the product is not functioning with respect to the customer needs, then throw the design, then go for redesigning, then go for redesigning the model. So that is what is called as response values. So here cost, you can analyze the cost if the product is functioning. Example, okay, for the particular load, you have done the analysis that after getting the post processing results, okay, you analyze that this product is functioning with respect to the customer needs. Then you should analyze what is the cost, how much I should invest. If you go for real manufacturing, from the virtual to real manufacturing, so what is the cost involved? Then you should analyze what are the machines are required. So what is the how much raw materials is required for producing one product? So how much manpower is required? So everything you should analyze and you should mention the cost. So what is the cost? Okay, cost I should invest when I go for real manufacturing. So this figure tells everything. That's about CAE, that is computer aided engineering. Be careful, computer aided engineering based simulations. That is your FEA, that is finite element analysis. In finite element analysis, all the software will come into picture. Your CFD, that is CFD, computational fluid dynamics, ANSYS Workbench, Abacus, Nastran, Patron. So all the softwares will come under the CAE, that is computer aided engineering. So any doubt, students? I can go for next slide. So this is the last slide, okay, which I'm finishing today. So any doubts in this? Kindly should mention, students, the previous slide. If you have any doubts, you can ask me so that I can go for next slide. Fayaz, Rahul, as well as Archana, do you have any doubts? Hello, hello, students, you should respond me. Okay, sir. Okay, Faiz. So this is the last slide, okay, which I'll be teaching today. So after this slide, vision of VM I will teach you. Classifications I will teach you tomorrow. Means after the test. Okay, I require 2 hours of time to complete the fifth module. Okay, I'll complete later after the test. Anyway, this is the virtual environment. So see, virtual environment is nothing but you can see from definition the computer generated 3D representation of a setting in which the user of the technology perceives themselves to be and with in which interaction takes place. So this indicates okay 3D is nothing but 3D modeling. So I am telling you 3D indicates the 3D model. Let's see, we will use the computer and software like SolidWorks, Creo, okay, to convert your sketch prototype into the 3D modeling. So we will use the 3D modeling and we will use some technology, that is softwares, okay, to see okay how it behaves. So this is nothing but virtual environment. Okay, virtual environment. See when you play the when you play the see when you play the like games, okay, in your phones. So that's called as virtual. So you are seeing the virtual environment. So when you play the car games, okay, so that's called as virtual. So you are not so you are not means riding means you are not moving the car the practically. Okay, so you are playing or you are driving the car. That is with respect to some softwares. Okay, they will build a software I think if you play the PlayStation, okay, in your home, so that's called virtually. So you will be playing the games, or you will be moving the car virtually, not the practically. So this is nothing but a 3D representation. That is a model. They will create a model of the car, and they will create everything. Okay, with respect to some technology, they will use the technology. Okay, that is called virtual reality. So that is that is so that will interact, okay, with each other. So if you're playing, you will feel that, okay, I'm riding the car. Okay, so right now there is a virtual reality softwares. Okay, you can put the, these softwares with a put in phone. Okay, and you can play okay, easily. So this is called as virtual, what you can say, virtual environment. Okay, which is created, and we will be trying to play the games, or whatever it may be. Okay, we will be trying to analyze, and we will be trying to move virtually. Okay, like this, if you go for the companies, okay, everything, so everything they will be trying to analyze virtually first. Okay, then they will implement to real world or real manufacturing. Okay, so you can see here, so there's a sketch here. You can see the sketch. In this sketch, you can analyze everything. See, first is product design. So I told you this product design will be done by the uh, product design engineer. First, they will be design thinkers. Okay, they will get the inputs from the customers. Okay, then they will send these inputs. Okay, to the product design engineer. So those inputs are called as, those inputs will be given by the product design engineer. Sorry, those inputs will be given by the design thinkers. Then they will take the inputs from the design thinkers. They will try to find the what you can say, the model according to the customer needs. Okay, they will design the model. So next you can see here VM environment. Okay, in this VM environment is nothing but, okay, it will store the database. Okay, so that means database is nothing but how should the model should be viewed. Okay, in the virtually, not with respect to real. Okay, real manufacturing is different. Virtual means we are creating the modeling in the system or in the computer. So how the model should be viewed in the computers. So that is called as database. It will store the, see, model. It will store the device model. Okay, and it will see the product model. Okay, everything, and process model, everything we can store in this VM environment. Okay, once it is stored, or even once the design part is finished here, see, after product design engineer, he has given the design, original the design to the virtual manufacturing environment. Okay, here what we will do by using the softwares like Creo or SolidWorks, we will try to model the 3D modeling. So once the 3D modeling is finished, okay, after that we will do the simulation. Okay, once we do the simulation, that is your analysis. Once the design is not good, then it will go for virtual reality. You can see here. So there's a term like simulation manager and virtual reality. So once in simulations, if you get that the material is not safe, okay, for this particular load, or for this particular boundary conditions, then automatically, okay, we will see in virtual, with respect to virtual reality, again it will go for designers. Okay, so once you get the negative results here, we should see virtually, we should see virtual, by using the virtual reality we should see the model. Okay, if the design is not good, again it will go for designers. Again the designers will send, this design is not good. Okay, the design, what the product design is provided, it is not good. Then again the product design engineer will look into the design. Okay, where actually the material is been failed. Okay, then you will try to redesign the model. Again you will send to VM environment. Okay, again the VM environment, what they will do, they will design the 3D model. Okay, they will consider all this effect, that is process model, product model. Okay, then modular, everything they will consider. They will store the database. Again they will do the simulation. So once the until the simulation get the positive results that the material can withstand the load, then the simulation engineer will send to the simulation interface. So interface is nothing but, here you can see there is a real device, system, then users. Okay, so after once the simulation engineer, sorry, simulation interface. See, interface is nothing but, the real device is nothing but, okay, when you go for the real manufacturing, there is the actual manufacturing. So system is nothing but, okay, we will see in system interface. So see here, initially we will do for an product. This simulation interface is nothing but assembling all the parts. If you go for car, okay, initially we can solve for one part. So at the end, you should solve for all the parts, right? That is called a simulation interface. So you should solve for all the parts, and we should see whether the material can withstand all the loads. Then, okay, that is system. We will do everything system. If it is okay, then we will show for the then you will show the product for the users. Okay, then the users tells, okay, we are fine with the product. Then it will go for real device. That is, we will convert the product into reality. That is your real manufacturing. It will go for real manufacturing. Here DFM and DFA is nothing but design for manufacturing and design for assembly. So we will test everything here. See, in simulation interface, you can see here we should go for design for manufacturing and design for assembly. I told you, right? So initially we will check for part. We'll check, the simulation manager will check for the part. So at the final, okay, once you've done this design for manufacturing and design for assembly, so here we'll check for design for manufacturing for each part. Then we will go for design for assembly. So once design for assembly is over, then we will check for throughout the assembled product. Okay, in the system. So once, if we get the positive feedback or positive results from that, then we will show the design, the original design for the users. If the customers are satisfied with the results as well as the product, then they will say, okay, go for manufacturing. That is real manufacturing. Then only your real manufacturing will come into picture. So this is the environment of VM. Okay, this is the this is how the industry works. First product design, then it will come for VM environment. They will create the 3D modeling. Then by using the simulation software, so the simulation manager will check the product whether the material can withstand or not. Okay, if it withstands, then it will go for simulation interface. Okay, in simulation interface, DM and DFA will be used. So DFA, design for manufacturing, but is by using the virtual reality. Okay, you can use the virtual reality is nothing but, okay, you are seeing the product virtually, not really. That is by using the softwares in the computer. Okay, you will be seeing the product virtually, not really. That's called virtual reality. Okay, you will be seeing the product like a real. Okay, in the systems. So only as mentioned, virtual reality. So simulation interface, they will see DFM and DFA, design for manufacturing and design for assembly. They will check. Okay, once the product is okay in the system, okay, in the original in the computer, then they will show the product for the users, that is customers. The customer satisfied, then it will go for real manufacturing. So this is the environment of VM. That is environment of virtual manufacturing. So if you have any doubts in this, you can ask me. So this is how it will work in industry. Okay, so you should know what is simulation, what is system, what is DFM, what is DFA, what is product design, what is designer job, what is design thinker job. Okay, so what it will be doing in VM environment. So only thing is, VM environment will store the database. Okay, so whatever the 2D drawing, sorry, whatever the sketch prototype which is given by the product designers, okay, they will take and they will try to convert the sketch prototype into 3D model. Okay, that is by using the some modular softwares. Okay, then they will see the process models, as well as, okay, they will see everything, how the 3D drawing will be completed. Okay, by using the softwares. So then vision of VM. What is the vision of VM? Okay, manufacturing the computers. I told you number of times. Virtual manufacturing is nothing but manufacturing the computer. Provides a powerful modeling and simulation environment. I told you. So first we will model, and then we will do the simulation, and we'll find the results. Okay, later on, if the material is withstanding the load or the boundary conditions according to the customer needs, then we will go for real manufacturing. Until then, okay, we will be trying to remodel the structure or remodel the product. Okay, so here you can see, first is opportunity. Okay, opportunity is nothing but according to the customer needs. Okay, whatever the customer needs they are given, that's called opportunity. Then, okay, we will generate the 3D model. Okay, by using the computers, we will solve the problem. Okay, we'll solve the problem, or we'll solve the 3D model. Okay, by using the softwares like ANSYS, Abacus, Nastran, we'll get the results. We'll get this is called as information. Information is nothing but, if you want to change the model, if you want to control the model. Okay, so all these things we can do in virtually. First we will do virtually, then, okay, first we'll make everything in the computers. Okay, if it is okay, if the product is okay with all the boundary conditions or all the customer needs, then it will go for the real manufacturing. Then you want resources like manpower, raw materials, then equipments, machineries, technologies, everything we want in resources. Then we will convert. Okay, we will take all the inputs from the virtually, whatever we done virtually, then those inputs will be applied, okay, in the real manufacturing, and we will make the products. So this is how, okay, we will convert the raw materials into finished product. So initially, before 30 to 40 years back, so this first make in computer was not there. Okay, only directly after the product design engineer, okay, after the sketch prototype is over, they were going for the prototype. They were manufacturing directly the prototype, and they were testing they were testing the product really. Okay, that means they were wasting the money, okay, for investing raw materials, for investing machineries, for investing manpower. So everything were wasted initially before 30 to 35 years back. So right now, okay, by using the virtual manufacturing, virtually we are solving everything, okay, in the systems, and we are finding whether the material, this product is good or not, whether the material can withstand the load or not. Everything we are analyzing in the system. Okay, then we can control everything in the system. Okay, whether speed or cutting speed. Okay, if you go for CNC machine, everything we can control virtually in the system. Then we can give all these inputs, okay, in the while manufacturing the real products. We will take the inputs from the whatever we solved in virtually. These inputs will be given, okay, in the real manufacturing products. So this is how we are solving now. Okay, from almost from 10 years, the top companies, if we can go for Bosch or we can go for Wipro. Okay, so Infosys, everyone will be using the VM, that's virtual manufacturing, to convert, okay, the raw materials into finished products. Okay, so this is very, very important, virtual manufacturing, if you go for the MNC companies. So by this, I think it's 223. From classifications, I will do after the test. So do you have any questions with regarding to these slides? Because these are the questions I've asked in the test. So if you read from virtual product development to the vision of VM, so that's enough. So in test, kindly write need sketches. So if you write more sketches, then it will be easy for you to explain. Okay. So if you write more sketches in PLM also, see product life cycle. If you see the textbooks, so there's no figures. Okay, there will be no figures, but always I will be trying to explain, okay, for you with sketches, because sketches can teach more for us than words. Okay, so if you write sketches more, see, always I will write the sketches. Okay, everywhere I will be writing the sketches, because we can explain easily. Okay, if you write in the form of words, then it will be difficult. Okay, see, always you should write the sketches. Okay, wherever you go, you try to write more sketches. Mechanical field involves more sketches, so you write more sketch and explain less, so that will be good. Anyone has any doubts in this today's class, you can ask me. By this, I think I completed for the test. Okay, I completed till test. Later on, after the test, I will take 2 hours to complete this module. Okay, this 5th module. So any doubts, I will add my PPTs and as well as notes. Okay, within next half an hour, so that you can read for the test. So any doubts, students? Fayaz, as well as Archana, Rahul, Tippesh, any doubts, or I can end the class? Rahul, you have doubts, Rahul?
No doubts, sir. No doubts, sir.
Okay, so by this, other students, if you have doubts, you can ask me. Okay, if you have doubts, you can ask me, so that I can explain. Otherwise, I will end the class. So if you have doubts regarding to the caption project also, you can ask me now. So